Hello, my topic is Introduction to Transactions and their importance in ensuring data integrity. So, what are transactions? Transactions group a set of tasks into a single execution unit. Each transaction begins with a specific job and ends when all the tasks in the group are successfully completed. If any of these tasks fail, the transaction fails. So, basically, let's say a transaction has 5 steps, like in the example diagram. So step 1 is the beginning of the transaction. In step 1 the transaction begins. It goes to step 2. And let's say in step 3 the process or the operation fails. So what will happen is the transaction will fail, the overall transaction will fail. So in order to complete the transaction, it needs to start again. It needs to complete step 1, step 2, step 3, step 4, and eventually step 5 needs to be completed in order for the transaction to be completed. These are some of the examples of transaction processes, like in a batch of processing where multiple rows must be inserted, updated, or deleted as a single unit. Whenever a change to one table requires the other tables be kept consistent. When modifying data in two or more databases concurrently, and in distributed transactions where data is manipulated in databases on various servers. Now let's come to the properties of transactions. ACID properties. It stands ACID. It stands for atomicity, consistency, isolation, and durability. Atomicity pretty much states that a transaction can either be completed successfully or will be a failure. There's nothing in between. The whole transaction must be rolled back if any part of it fails consistently. Transaction maintain integrity restrictions by moving the database from one valid state to another. Then isolation. Isolation states that a transaction multiple in if there are multiple transactions, each transactions are isolated, which ensures the accuracy of the data. And then durability. Once a transaction is committed or a transaction is completed, the changes remains constant even if there is a system failure. So why are ACID properties important? ACID properties are important because it has some key benefits. For example, data accuracy. ACID ensures that data modifications are accurate and complete, minimizing errors and discrepancies. System stability. ACID transactions prevent data conflicts and maintain database consistency, leading to a stable and reliable system. Then increased trust. ACID guarantees data integrity, fostering trust and confidence in the system's ability to handle sensitive information. And finally, improved efficiency. By preventing errors and inconsistencies, ACID reduces the need for rework and data correlations. So finally, transactions in SQL are a cornerstone for data integrity and consistency, providing a framework for managing sequences. Through the ACID properties, transaction ensures that the database remains in a reliable state even in the presence of failures or concurrent accesses. And by understanding transaction management and their best practices, developers can build robust applications that maintain data integrity and operate efficiently in complex environments. Thank you.